This video demonstrates how to create a UART communication project using the Smart Configurator in eSquare Studio. In this demonstration, a computer transfers ASCII characters to a target board. The target board then analyzes the data, generates responses, and sends them back to the computer. If an error occurs, the target board sends corresponding error data to the computer. For this demonstration, we will use a computer with eSquare Studio installed, a E2 Lite as the emulator, a Renesas RL78G 2364-pin fast prototyping board as the target board. First, connect the USB to serial converter via a micro USB Type-B cable. Then, connect the E2 Lite and short-circuit pin 2 and pin 3 for J8, J9, and J11 on target board. We will use eSquare Studio IDE for this demonstration. You can refer to this video for the installation steps. RL78 Smart Configurator plugin serves as the development tool, generating UART communication driver code based on your GUI settings. For this demonstration, we will use the Terra term as the serial terminal, which is available from the GitHub. The terminal settings should match the Smart Configurator's UART GUI configuration. Next, we'll show you how to create an RL78 project in eSquare Studio. From eSquare Studio toolbar, select a Renesas RL78 project. Select the project type. Enter the project name. Select target device that you are working on. In this demo, we select R7F100GLGXFB. Confirm that the Use Smart Configurator checkbox is selected, then click Finish. The project is created successfully. Now, we will configure the UART communication component. Click Add Component button in the Components tab. Select UART communication. Choose Transmission Reception Mode. Select UART 0 and click Finish. In the Components tab, configure Transmission tab and Reception tab. Confirm there are no errors in the Configuration Problems window. Click the Generate Code button and then proceed. A code generation successful message will appear in the console window. Next, add user code and run the project. Open the UART demo.c file, which contains the main function. Declare global variables for UART status, the receive buffer, and private global variables for sending data to the computer. Set the receive buffer and enable UART reception. Add a while loop in the main function. Add code to handle reception errors and send response data. Add code to analyze normal reception data and send response data. In the config UART 0 user.c file, add an external declaration for the global flag in the user code area. Set transmission completion flag. Read the error flag. Clear the error flag. Each callback is triggered by its respective interrupt function. In the Project Explorer, right-click the project name and select Build Project. Confirm that there are no errors. Right-click the project name and select the debug type. Click Switch to open the debug perspective. Click the Resume button to continue the program. The program will stop at the beginning of the main function. Click Resume again to start execution. When the computer sends the capital letter T to the target board via the serial terminal, the board returns OK. When the computer sends the lowercase t, the board returns OK. Sending the number 1 results in the board returning UC. If the terminal's parity setting is changed to odd, sending lowercase t will return PE. If other errors occur, the board will send data corresponding to the error. For more information about Smart Configurator, please refer to the Renesas website.